G'day viewers. Today we would like to take a look at our revised SYSDEF prototypes. Currently our range has 33 varieties of prototypes, which includes A1s, A3s and A4s. There were three main drivers behind the revisions for these latest Advance Steel prototypes. The first was to include lot and phase separation into our drawing automation system. The system can now accommodate separation by work areas, and now those work areas can also be separated further by creating a lot and phase within that work area. The second driver was to increase the size of the text in the title blocks to make it easier to be read by tradespeople. I felt that our previous prototype design went too far when squeezing the title block in order to provide as much drafting real estate as possible. Our previous layout probably squeezed that a touch too much. After all, workshop fabrication drawings are intended to be read in workshops, which aren't always the best well-lit environments for reading documentation. So anything that we can do to make that better, to assist on that front, should be well received. The third reason for updating the prototypes was to add our new general engineering notes to our existing general fabrication notes. We have also added some abbreviations and prefixes to these drawings. Let's firstly take an overview look at the revised list of prototypes in the system. Okay, here we have our list of 33 prototypes. We can see that our first 1 to 6 prototypes are for our general drawings, and then we have a group from 7 through to 14 which will be for our engineering type drawings. Then we have from 15 to 19 we have our marking plan prototypes. 20 and 21 are the assembly, which are the stick assemblies and the welded assemblies. Then we have our single parts for our mild steel, our single parts for our components. We have our single parts for our light gauge steel and our single parts for our cleats. Now they are all the A1 drawings. Now from 26 through to 30, these are all the A3 drawings. Now we do use them quite a bit, particularly for the smaller components, so particularly for single components and for cleats. We don't put our single cleat drawings on an A1 sheet, we would put them on an A3 sheet. Now from 31, 32 and 33, these are A4 sheets, and typically we don't use those drawings very much. So the majority of prototypes that we would use here or we see being used are the A1 sheets and a couple of the A3 sheets, which are used for the smaller single component drawings, purlins and cleat drawings. Secondly, let's now take a look at a comparison for the old design of the prototype and the new prototype layout. So here we have a side-by-side comparison of the old prototype, and on the right hand side we have a version of the new prototype. So the first thing that you will notice is that the area allocated for the project and drawing details has increased. So on the left hand side we can see that's quite narrow, but on the right hand side we have increased the size of that area. This was both to allow for an increase in text size and to increase the space between the lines, which I felt was too tight, particularly in light of the fact that from moving away from block letters and using upper and lower case in the title block, and with the notes more generally using an upper and lower case, that having this space, particularly with letters like the letter G, where you have something under the line would clash with the next text. So increasing that space between those text lines improved the readability. If you look at the document number, so we're looking down here, so we now include the lot and phase. So if we can zoom into that area, zoom a little more, so you can see here we now include the lot and phase. If we go back to our old layout, you can see here that we had a project number, an area number, then we're into document type, and then our document number. We didn't have an allocation for the lot and phase in the old title block. The new title block, however, does include the lot and phase. So now, as our file name and our document number matches, we have our project number, our area and building number, our lot and phase, our document type, and then our document number. We then have our sheet number here. So what sheet number that would be. One thing to note, I'll just zoom in again. You can see here we've got the sheet number. Unfortunately, Autodesk don't offer a token for prototypes for the sequence number, which is what we use for the sheet number. This turns up in the file name, but it's not a token that we can actually use in the prototypes at this time. So it would need to be manually edited until such time as that functionality is included in the Advance Steel Foundation software code. Something else that we did with the new prototype, we can see that our drawing status box was only short, or didn't extend all the way to the end. I've extended that now to come across all the way through to that line. I felt that it helped balance that box and just cleaned up that drawing status box area. This is where you would put your what we used to call our stickers, our for construction, our not for construction, preliminary statuses for our drawings. Right, let me just zoom back out again now. Okay, let's now take a deeper look into our drawing prototypes as individuals. Right, so here are our general drawings. The cover page text is automatically created from the project's setting data, although the 5 user attributes have been customized to contain the engineering design load criteria. So you can see here that these 3 lines, the wind region, the terrain category, and the importance level, are coming from our project settings, but they are under the user attributes. We also include on our cover sheet the drawing set breakdown to assist with understanding the flow of the drawing set. This is not overly intelligent text. This is simply some M text which can be manually edited. For instance, the drawing for engineering drawings may not be required for some plans that can be removed. So here we have an allocation for the engineering drawings. However, some clients or some projects may not require engineering drawings for that particular project. They may only be the fabrication type drawings. So that could be removed and you can go straight to marking plans. So this is a manual editing for a project. Here we have our general notes. So we have our general notes here for sheet 1 of 2 and 2 of 2. These are our new engineering notes. These are our old existing fabrication notes. However, we've added a new second sheet to that group to add abbreviations, and also we've added our model object prefix. So this may help a reader of the set to understand some of the abbreviations which will be used, like RFT for rafter, to help them understand what some of the terminology that we use in the set. Now this can be customized obviously for different prefixes that others used. However, I feel that having a national Australian standard for these prefixes may benefit the industry as a whole. Next we have our 3D isometric view. We only have the one 3D isometric prototype that has been created, and it is possible to have many 3D isometric views, and it is just a matter of manually editing the text. Like you may wish to have the north or south view, or 3D isometric view 1, 2, 3 when you create your drawing, but that would be a manual edit of that text once those drawings have been produced. Now we can automate that process for the drawings to be produced. It's just that the text itself would need to be manually edited to give it the name or the title that you would like to call it, as we can't use the parameters from the model to populate those texts at this point in time. It should be noted for the general 3D isometric views that cameras weren't intended for use in these particular drawings. These particular prototypes, it was intended that X references would be inserted into the model space, into these prototypes, and viewports created to visualize the 3D model. The intention of these particular drawings at the early front of the set is to provide the reader of the set some visual understanding of the scope of the project, and give them some insights to the scale and what sort of project it is. It would be possible to add some labels in paper space should that be required, if you want to talk about particular phases or certain areas on the project. But the intention of the general 3D isometric views is to provide an overview of the project and a visual understanding of the scope of the project, which should be enough as a starting point to help build up the reader's understanding of the drawing set. Our next prototype is our engineering 3D isometric view. So this is where we would, or it is intended that cameras are used to create the drawings, which will have labels and information and presentation as required. It should be noted that no assembly or parts lists are added to these particular prototypes, as it is a general drawing. So here we have our first group of engineering drawings. So we have our general arrangement. So here you can see with the text, our general arrangement, column layout. This text here can be edited to match what sort of general arrangement drawing is created. So whether it is just a general set out arrangement or whether it is an actual column layout. We have a specific one for roof layouts. So if you're using your camera to create a specific roof layout, it would be put onto this drawing, but you wouldn't have to change the text. It would already happen. Here's our elevations, engineering sections, engineering details. Here are engineering hold down and layouts. The engineering hold down layout and the set out share the same prototype. This is where, yes, you can create a layout of the hold down bolt and then a set out which will give you your hold down bolt dimensioning. They use the same prototype, but it would be a manual process to remove the text that is not required for the specific drawing that has been created. We have one for a support layout, our isometric view for our marking plan. So that was the end of our engineering drawings. We're now into our marking plan. So we have specific marking plans in 3D isometric views for marking plans, where the engineering plans for the isometric views will talk about the section or profile, whereas a marking plan will actually be indicating its specific number. So if it's column number 10 or rafter number 2, as opposed to indicating that it is a 250 UB or a 250 PFC, that would be shown up in the engineering drawings. So we have marking plans. Once again, elevations. These are all marking plans to indicate which assembly or part number the fabricators will need to go looking for. We've got also some prototype for specific fabrication details which may be different to details created for the engineering. In the next group, we have our assembly for sticks. So there are two assembly prototypes, one for stick assemblies and one for welded assemblies. They are slightly different in how the bill of materials schedule template that's included onto these prototypes work. So there is a slightly different method to how that information is produced on those drawings. So now we come into our single part drawings. So these are single part. This is an A1 prototype. So this is where we would include just a single part for our mild steel. This is where you would have information for the single part for a rafter, column or stringers, some of the larger mild steel component parts. The next prototype is for single part components. Now, typically we would see not an A1 prototype being used, but rather an A3 prototype being used for single part components, as these components are typically the smaller elements like tread brackets or outriggers, rod bracing, folded plates, those types of model objects and elements, which are normally smaller, which don't require an A1 sheet, which would better suit the A3 sheet. Now, that is based on a model roll of which elements are shown as a single part on an A1 sheet or on components. That is managed by model rolls. Again, light gauge steel, we would typically see our purlins that they would be shown on an A3 prototype as opposed to an A1, but we do have an A1 sheet for those cases where either a client request or it is necessary to produce the light gauge steel on an A1 sheet. Murphy's Law will say that you need to have these. If you don't have it, then it will be requested for sure. Again, single part cleats at A1. Yes, there may be cleats that require an A1 sheet, but generally speaking, an A3 sheet would suffice for single part cleats. There may be cases when particular clients may want to put multiple cleats on a drawing when an A1 sheet makes sense. So it has been included in our prototype set. Now we're into our A3 sheets, mild steel, components, light gauge steel, cleats. So we have our standard library parts as well. So this is when parts are coming from your standard library parts, not your non-standard project-specific parts. And then we're into our A4 sheets. So that is the end of our list of the SYSDEF prototype parts. With that, I have two questions for the users of the SYSDEF Advance Steel system and to the broader Advanced Steel detailing industry. With our title sheets, if I go back to our title sheets, my question would be whether only having 2 rows allocated to denote the address for the site is sufficient, or whether 3 lines is required. And secondly, we currently have three lines or 3 rows of text allocated to indicate the drawing description. The first line indicates the drawing set group, so whether it be the general set or the engineering set, marking plans or single parts. That is indicated in the first row. The second line is used for a description, whether it be like a camera description or column layout or a model roll. In the case of a single part, we will then have the model roll before using the third line, which would then have the assembly number or part number. So we've got 3 lines allocated at the moment. So I'm interested to hear whether others are also using 3 rows, or whether the using 4 rows is generally what others are using. So with that, I'm always interested to see how other users are implementing their advanced steel system, and open to ideas and practices that are being used by others. What we are aiming to achieve here at SYSDEF is to provide some flexibility in the system. However, at the core of what SYSDEF is trying to do with its advanced steel automation system is automating the process to try to get as much automation into the drawing production and the output from the models to save time and create efficiencies in the drawing production side. So many of the systems that we are devising are aimed at improving the automation system that can be achieved with advanced steel, but you must have those core foundation systems in place for those to work. So with that, just remember that if your job's worth doing, it's worth doing right.